Here we go again with some more lengthy word problems that have really good results. The statement today reads, prove that the average magnetic field over a sphere of radius capital R due to steady currents inside the sphere is BAV equal mu naught over 4 pi 2m R cubed, where m is the total dipole moment of the sphere. Contrast the electrostatic result. Thus, B average is equal to 1 over 4 pi r cubed times the integral of B d tau. Show that the average magnetic field due to a steady current outside the sphere is the same as the field it produces at the center. This looks familiar, sounds familiar. Let's look at it. So we have some sphere here, r prime vector out to the surface, which is leading to our volume element d tau. And that has a separation distance to the surface dA. Alright, now let's modify this. So now we're just looking at the shell as sits, and we can put the prime coordinates up with the separation vector all lined up on the z-axis with theta as such. Again, typical tools to use here for these problems. Alright, so let's start with the average field. If we know that B average from the statement page is 1 divided by the volume of a sphere, then we'll just knock that 3 up, simplify it down. But we know that we can write the magnetic field in terms of its vector potential, which we do have, or we can use later. So that's just the curl of A, okay? Now we have the curl of something in a volume, so we could write that via the integral theorems to the closed surface integral of A cross dA. Again, put your minus sign there, just be careful. But we know here that A itself is the integral of J over script R d tau prime. So we put that in there for A. And now we just have to solve this through. Noting, however, that the J is what's being crossed. And so we can push the integral to the closed integral inside. And now we just have to define everything for this geometry and plug away at the integrals. Note that J depends on the source point R prime, not on the field point R, hence the swap. To do the surface integral, choose the XYZ coordinates so that R prime lies on the Z-axis, which we showed on the last page. Then script R, thanks to the law of cosines, is equal to the square root of r squared plus z prime squared minus 2rz prime cosine theta, while dA, the normal spherical surface element, is r squared sine theta d phi r hat. So by symmetry here, since we put it on the z-axis, x and y components must integrate to 0. And since z component of r hat is cosine, we have the following integral. The closed integral of 1 over script r dA is equal to z hat 0 to 2 pi 0 to pi of cosine over script r, with this is in terms of the square root definition with the dA element. We know that there's no function for phi here, so thanks to Fubini's theorem we can push that out and get 2 pi. R squared is also a constant, so we just get 2 pi r squared outside. And now we're left with this gross integral with a bunch of sine and cosines. So u sub is in order. Let u equal cosine theta, then du is equal to negative sine theta d theta. If we evaluate the bounds, u of theta is cosine of, or u of pi is equal to cosine of pi, which is negative 1, and u of 0 is equal to 1. Note that we have a negative on the du term, we have a negative that will come on the du term, but we also have the order of integration that we can flip to cancel the negative. So in the next step, we'll just combine those. So substituting and flipping the order of integration, we get this integral. Now it's just a matter of chugging it through, which turns into a hot mess. So for all the calculus lovers, have fun. We see here on the next page, it simplifies to a piecewise definition for when r prime is less than r, big R, the surface of the radius of this shell, and then r prime greater, okay, pushing that through. For this first part, however, we want the case for where r prime is inside. So B average is equal to 4 pi r, or excuse me, 4 pi over 3 r prime vector. Okay, so 4 pi, factor of 4 pi cancels and the 3 cancels. So we move forward and we have negative mu naught 4 pi r cubed, the integral of j cross r prime d tau prime. But we solved earlier that the magnetic dipole was equal to 1/2 the integral r cross j. And thanks to the cross product being anti-symmetric, or not even anti-symmetric, but anti-commutative, i.e. r cross j is equal to negative j cross r, we can put negative 2m into that integral, and we do indeed see that the average field is what was given. All right, moving on to part B. This time r prime is greater than r, which capital R being the radius of the shell. So we use the other part of the definition, plug it all in, and we see that we end up with this expression here. Again, factor of 4 pi over 3 cancels. And we get mu naught over 4 pi j cross script r hat via definitions, since script r now goes from the source point to the center, i.e. script r equals negative r hat, or not r hat, r prime. So we see here that the B average is equal to the B at the center. Again, fantastic results.